Hello, my name is Andy Schweitzer, and this is a small video on single displacement reactions. This is for general chemistry. This is a simplified view of an oxidation reduction reaction, and therefore if you want more in-depth information on oxidation reduction reactions, you'll need to see a video on honors chemistry about that. But either way, how do I recognize a single displacement reaction when I see one? First of all, a single displacement reaction is going to involve an ionic solution. Let's say A, B. This will be my cation, this is my anion, and it will be an aqueous solution. It'll be in a, let's say, a beaker where we have A cations. I'm just going to draw this as probably could use a little bit more room here, but I'm going to, let's put it right here. A bigger beaker, and A beakers are ionic compounds, so we have cations and anions just kind of floating around. All right, and we'll react this thing with some sort of pure element. This can be either a metal or a non-metal. Metal or a non-metal. Now, so plus some piece of metal, and this will be a solid chunk of something, or it could be liquid, some pure substance. Usually we'll have it be a solid. Drop it in there and a chemical reaction occurs. On the below here it says, how do I write up my products? Well, if this is a metal, and of course this is a metal, and this is a non-metal, metals replace metals, non-metals replace non-metals. So Y, being, let's say, a metal, would replace A. So Y would become now the cation, B would still be my anion, and A would be all by itself. There would be no charge. So if it's a non-metal, then it would replace the non-metal. Very important. Okay, metals replace metals, non-metals replace non-metals. We'll see some examples of how this works as we move along. All right, so here's an example. I'll just kind of erase this and we'll start over and see how this works. So, writing out a single displacement reaction. All right, so let's say I have AgNO3, and let's add this thing to copper. All right, so this is my ionic compound, so people often recognize this as being a double or an ionic compound in a single individual. This is indicating me that this is a single replacement or single displacement reaction. Those words are interchangeable. Single replacement or displacement, same thing. It's referring to this oxidation reduction reaction. This is the cation, this is the anion, this has no charge. All right, so because copper is a metal, it replaces the silver. And I'm getting copper NO3. Now, this is a -1. The copper has multiple options, +2 or +1. Only way to know which one it would take would be to do it in lab, and different conditions might yield different charges. So just for the sake of being a little more challenging, I'm going to make it the +2 version, and therefore 2 goes here. And then the silver is now by itself. Okay, and that is it. Another example with a non-metal would be, let's say, NaF plus chlorine gas. This is a non-metal. Non-metal replaces non-metal. We get NaCl plus F. Now, fluorine is a super 7 diatomic molecule, so just in nature, it happens to come in pairs. There we go. Now, the next option here, and I'm going to flip to this slide here and say, how do we know if a single displacement reaction actually works? Okay, and for that we need to use what's called an activity series, and I have an activity series right here. This is the one that's on my website. It'll be given to you, and from this, the question is, can the single individual actually replace the one that's in the ionic compound? Okay, and again, this is a very simplified way of looking at it, but this is the rule. If the single individual is above, then it will replace. You can go and write that on your sheet. Or another way of putting it is the single individual can replace anything that's below it. Okay? So you can replace anything that is below it. Okay? Let's go back to our actual chart here. Okay. Which of these would work? Okay, so we have copper here is a single individual, and it's attempting to replace the silver. Can copper replace silver? Here's copper, and copper can replace anything that is below it. So the answer for this is going to be yes. Silver's right here, so little smiley face. Okay. It can replace it. This is going to work. And let's go back to our thing here. It is yes, it will work. Smiley faces, it will run. And therefore we'd balance it. 2 nitrates, 2 nitrates, 2 silvers, and 2 silvers. All right, let's check this one out. Can chlorine replace the non-metal? All right, so we have this situation here. Let's look on this guy. Now, the non-metals are on this side. All right, chlorine can replace anything that is below it. And unfortunately, that's bromine iodine. It cannot replace fluorine. So, this one is a no-go. So, a little frowny face means it will not run. You can balance it if you like, but really, on paper, we're saying this is going to occur. But in reality, it is not going to happen. So, you would write no reaction. Okay. Few points here that you want to make sure you don't screw up, or things that kids tend to cause problems with. Make sure when you write your products out here that you balance your charges for the ionic compounds. Don't forget the molecules that are standard diatomics. Don't forget to look on your activity series to see if the reaction will actually work. Other than that, that's basically it. Thank you.